Okay, in this short little tutorial here, I'm going to show you how to use your calculator to convert numbers from decimal to hexadecimal to binary. All right, and I just have my Windows, I'm on my Windows platform here, and I have my Windows calculator. And one of the cool things about this is a great little tool. There's actually 4 different views that you can use with this. There's a scientific calculator that you can use, where if you need to use any trigonometric functions, or logarithmic functions, or go from radians, degrees, all that stuff, that's in the scientific calculator. There's also a programmer's calculator here that I'm going to focus on today, and that's what we're going to use here. Okay, and the programmer's calculator is very convenient, because if you look here, here's hexadecimal numbers, decimal numbers, octets, and then binary numbers too. All right, so let's try and convert some numbers here. All right, so let's just take the number 8. All right, I put that in, and I'm going to use the number 8 as a let's see it as a hexadecimal number. All right, this hexadecimal number, it's going to be, oh, it's 8. Okay, well, that's no big surprise, is it? Let's look at the binary form of 8. Okay, and that's 1000. Excuse me. Okay, so just by clicking on these buttons, I can convert these back and forth. All right, let's apply this. All right, so I got right here, I have my, remember this, dog, and we converted to ASCII, using ASCII table to numbers. All right, here's the decimal and here's the hexadecimal. Let's just kind of try to apply this a little bit here. I think I can get both these on the same screen here. We'll try. Alright, so if we want to take, I think I can get them both on here. Alright, so 68, let's start that as a decimal number. Clear that out there and hit 68. And now if we want to convert that to a hexadecimal number, 68 is 44 as a hexadecimal number. Let's convert it to a binary number. Alright, so we'll put the binary equivalents of this here. So it's 1, 1, 2, 3, 1, 1, 2. Is that correct? I'm going to try and show these as one of the nice things that we try and do when we write binary numbers is to break them into kind of half bits, 4-bit blocks. That's usually the convention with them. All right. Okay, let's do another one here. Let's say if we have 6F, we can put that in there, right? Clear all this out. You notice these show up here now. We got more digits. So go hexadecimal 6F, and we want to convert that to binary, which should be 111. So we convert that to, or excuse me, decimal, and it is 111. Now let's convert it to binary. Okay, and so we're going to have 0, 1, 1, 0, and then 1, 1, 1, 1. All right, so that's the equivalent of 111 or 6F. Okay, so there's my O. Stretch this out so I don't run out of space here. Last one I got is the G, which is 103. So I go back over here, clear this out, start with a decimal number, 103, convert that to hexadecimal, I get 67, which is what I have down here. I convert that to a binary number. Alright, let's write that now. Okay, so it's going to be what? 0, 1, 1, 0. It's the first half byte, and then the second half byte is going to be 0, 1, 1, 1. Stretch all that out. Okay, so here is the ASCII table, how we would represent dog as a decimal. Here's this as a hexadecimal, and here's actually how it's encoded in the system. Alright, so now we're down to a series of bits, and they're either on or they're off, and this is how we represent these 3 characters.